On completion of the desoldering of the component termination, each lead should be checked prior to removal of the component using a probe or fine tip pliers. Move each lead to confirm correct solder removal. Each of the leads should move freely in the hole. If they do not, the joint should be resoldered using the soldering iron prior to desoldering. On satisfactory completion, the component may easily be lifted from the plated through hole without damage to the board or component. Solvent is evaporated from the solder paste to minimise the possibility of component movement and prevent solder balls due to spitting. Flux activation takes place to allow the cleaning of both component and pad surfaces. It also protects the surfaces during heating. Temperature stabilisation takes place so that the different temperatures on the board surface may be kept to a minimum. Solder reflows as the paste and termination point reaches the liquidous point of the alloy. When the termination points have reached the correct temperature, joint formation will take place. Cooling will start to take place as the assembly exits the reflow zone. This may occur naturally or may be accelerated by forced air or nitrogen gas. Correct profiling will require mounting thermocouple leads on the assembly to monitor the minimum and maximum temperatures. In the case of BGA, probes must also be mounted under the device. Either the leads can be placed under the part by drilling a hole through the component and connecting the lead to the board. Alternatively, the cable can be mounted under the device by drilling a hole through the board and fixing the junction to a pad. The assembly can then be passed through the reflow oven. In this case, two boards are being monitored as they pass through the process. They are both being monitored using a data pack profiler, which retains the information from the individual thermocouples. The key aspects of preheating is establishing the board temperature, normally quoted as topside temperature by most engineers and flux suppliers. Temperature labels are the simplest method of monitoring the peak temperature achieved before solder wave contact. As the board passes over the heaters, the indicator windows change colour from white to black to show the peak temperature. They must be placed on a represented area of the printed circuit board. An alternative and more accurate method of temperature monitoring is the use of thermocouples. In this example, an ECD wave rider is used which records the temperature rise through the process. The unit incorporates a data logger with thermocouples which are fixed to the base of the board. The general yields achieved on complex boards are also higher when using reflow soldering. A tape covering the reflow soldering process is available as part of this series. When using reflow soldering, a critical stage of the process is the printing of solder paste, which, when reflowed, becomes a solder connection between the board and component termination. Traditionally, companies have used screen printing of solder paste. Today, the trend is to stencil printing, using a metal mask to print high metal content pastes for fine pitch applications. Solder paste is a special material specifically designed to be printed onto the surface of a printed circuit board. Now let's look at some practical demonstrations of static electricity. Now here is the first simple example of static electricity. This little demonstration will allow us to hear a static charge. Here we've got a very inexpensive radio which has been tuned slightly off channel. So it's just on but off channel. Now the ladies in the audience will know about TV screens. They really are a problem. Unfortunately in their home they tend to attract dirt and debris. and unfortunately dust tends to be attracted to the surface of the glass, and this is due to a static charge. But this will allow us to hear a static charge by virtue of this radio. The radio is on, and I'm going to bring my hand into close proximity to the screen, and we'll be able to hear a static charge. So we could hear a static charge, although my hand wasn't in fact touching the screen. And one of the interesting things that it passed through my body and was picked up by the radio. So hence a simple example of static charge being heard on a small audio radio receiver. For this second example, we've got a liquid crystal display mounted to a simple printed circuit board. With this simple demonstration, we'll be able to see a static charge passing from one body to another. Simply by passing this printed circuit board to somebody in the audience, we'll be able to see a static charge. As you can see, the liquid crystal display is lighting up, showing that there's a static charge either present on my body or from the gentleman in the audience. So it's a simple demonstration of how charges can move from one surface to another.